So today we are going to work on some proportions. Over here, page 77. Determining missing lengths. Okay. So we're coming back to this idea of proportions, which we've already talked about once. So our objective is to determine missing lengths using ratios and scale factors. Okay. So we're going to go through 4 examples today. All right. Okay. Okay. So we're going to assume all the triangles we make today are similar. The first step, step 1, is to create a similarity statement. And even if I wasn't assuming that all of these triangles are similar, I could figure out that they are similar. Here's how. If I know the shapes are similar, we have 2 triangles, I know all of the angles are the same, then I know the shapes are similar. So if it's the same shape, I just need to show that all the angles are the same. These 2 angles are marked for me. So there's one pair of angles that are the same. These 2 angles are vertical, so I know that they're the same. Okay? So I've got one pair of angles that are equal, a second pair of angles that are equal, and I know the third pair of angles must be equal because, here's a little side note. Okay, these are both x. Let's say these were both y, or let's say these are both y, these are both z. Why are these 2 the same? Well, if I had 2 angles that are both y, 2 angles that are both z, and another unknown angle, they're both going to add up to be 180. So in both triangles, y plus z plus some unknown is going to be 180. Well, using some substitution and subtraction, I can show that these 2 question marks are equal because 180 divided by, or 180 minus y and z would be the question mark, and 180 minus y and z would be the question mark. So these 2 angles must be equal. So all 3 angles are equal and they're the same shape, so I know they're similar. So back to creating my similarity statement. I'm going to say that triangle ABC is similar to. Alright, now here's the hard part. I started with any 3 letters, now I need to match them up. What angle is the same as angle A? Well, that would be angle E. What angle is the same as angle B? Well, that's marked to be angle D. And what angle is the same as angle C? Well, that's its vertical angle, C. So now, I need to find what x is. Okay? So I'm going to set up a ratio. Oh shoot, I put these numbers in the wrong spot. Sorry. this should be 15, and this should be 3. Sorry. Okay, so I'm going to set up a ratio. Okay, and the first ratio I'm going to set up, I can either do big triangle to little triangle. That's what I'm actually going to do. So my big triangle, I'm going to call triangle EDC over triangle ABC. So this is how I'm going to set up all my proportions, with the big triangle on top and little triangle on bottom. So in triangle ABC, so keep in mind that ABC is going on the bottom, I'm going to set up a proportion. So triangle ABC, the side that I'm trying to find is AB. And in EDC, what side corresponds to AB? Well, that's ED. All right. The other side that I know in triangle ABC is side CB. Well, what corresponds in the big triangle to CB? That's DCD. So now I'm going to fill in my numbers. ED is 25 over X equals whatever CD is, 15 over CB, which is 3. To solve this, I'm going to cross multiply. So 3 and 25 and X and 15. So X is 5. Example number 2. Okay. All right, so they want me to find X. So I have to figure out which triangles here are similar. I see 2 triangles. I see triangle AEB, and I see this bigger triangle around it, ADC or ACD. I'm not sure which is equal yet. So I want to figure out, why are these triangles similar? Well, for the triangles to be similar, they have to be the same shape, and all their angles have to be equal. So let's figure out which angles are equal. These 2 little arrows mean that the lines are parallel. So this angle corresponds with this angle, and this angle corresponds with this angle. And angle A is shared by both triangles, so that's the reflexive property. A is equal to A. So when I write my similarity statement, triangle AEB is similar to triangle A. That's the angle they share. E, which corresponds to D, and B, which corresponds to C. So now I'm going to set up my proportion again. And I'm going to always go, well, not always, but in this case I'm going to do big triangle, and I'm going to compare it to the little triangle. Okay, or triangle ADC compared to triangle AEB. So I'm going to set up my proportion to find X. Okay, X is this length DE. That's tough. There's no side DE in any of these triangles because DE is not the side length of the triangle. Triangle ADC has a side length, but it's from A to D. So to find this length A to D, I'm going to use segment addition and say that AE plus DE equals AD. So it would be X plus 10. Similarly, BC is not a side of either of these triangles, but AC is the side of the big triangle. And to find that, I'm going to add up the 2 smaller parts of the segment and get 12. So really what I need to find is what X plus 10 is. And once I find X plus 10, I can find X. So AD is part of my big triangle. And that corresponds, AD corresponds with AE. And then the other sides that I know about, again, the big triangle would be AC. And that corresponds with AB, the smaller triangle. So I'm going to fill in my parts. And again, I'm going to cross multiply. Okay. Okay. So I can either distribute or I can divide both sides by 5, which is actually what I'm going to do because that's a lot easier. So I divide both sides by 5. I get x plus 10 equals 24? Yes, 24. Minus 10, x is 14. Okay, so I can like go through and solve it this way, or I can do this and get x is 14. So now I found x. So far those are 2 similar triangle problems. Okay. So the last example, I was going to do 4 examples, but I'm kind of getting a lot of time here. My example 3, I'm going to tell you that triangle ABC is similar to triangle DEF. And in fact, I'm going to even tell you the scale factor. Triangle ABC compared to triangle DEF is in a ratio of 3 to 4. So if I had triangle ABC, and I'll even give you the links for ABC, could we find X, Y, and Z? So these 2 triangles are in this proportion. So DEF is going to be bigger than ABC. So I'm going to set up my proportion, and I'm going to change things up a little bit. I'm going to get a little crazy. Okay, I'm going to do little triangle over big triangle. What? Okay, so that means I'm going to do triangle ABC over triangle DEF. Well, I want to find X first. So X is side DE, and that's going to correspond with side AB. But what do I set this equal to? I'm going to use this proportion to help me set up this ratio to help me set up a proportion. The little over big, so little over big is 3 over 4. So AB over DE is going to be 9 over X equals 3 over 4. I can cross multiply, and I get 36 equals 3x. 12 is x. And I'm going to do the same process to find EF and DF. DF, by the way, is supposed to be Z, not 2, if that looks like something else. All right, so again, I'm going to try to find EF. So again, I'm doing little over big, so EF corresponds with BC, and notice I'm always checking back to the similarity statement, not the picture, to figure out which sides go together. And that's going to be in the same proportion, 3 to 4. So BC is 15 compared to EF, which is Y. When I cross multiply, I get 60 equals 3Y, so Y is 20. And the last one I'm going to do, I'll do over here. I'm trying to find DF. DF is AC. And again, they're in the same proportion, 3 over 4. AC is 21 over DF, which is Z. I cross multiply, I get 84 equals 3Z, divide by 3, and I get 28 equals Z. Okay, that's where I'm going to leave it today. Sorry they're so long. Have a great evening.